Computational Tools, an Introduction to Mathematica and a Refresher of MATLAB. By the end of this section, you should gain a basic understanding of Mathematica and the syntax for using Mathematica. We're going to be using it in this course primarily to solve linear systems of equations, either those that have a unique solution, as many variables as we have equations, or underdetermined systems, where we will typically have one fewer equation than we have variables. We will use it to expand partial fractions for us instead of trying to do it manually, and we'll see how we can use Mathematica to solve linear differential equations. And as a second part, you will refresh your knowledge of MATLAB that you should already have coming into this course. We will be using MATLAB also extensively for graphical purposes and simulation later in the course. Here are the basics for this course of the software we're going to be using. If you've not used it before, Mathematica is a computer algebra system. So basically what that means is that Mathematica is able to manipulate symbolic expressions as well as numeric expressions. The way typically you've been using MATLAB, and most of the time the way you use MATLAB, is only for numerical calculations. What does this mean? We're going to be able to use Mathematica to solve equations with variables in them that are not defined by a number. So we're going to be able to do things like find x in terms of y, that you cannot easily do in MATLAB. I will say that MATLAB does have a symbolic toolbox that does keep improving. I, however, do prefer to use Mathematica. I think it's easier to use, and I think the output from it is a little bit friendlier to look at and interpret. But if you like using the symbolic toolbox at some point, that's also a good resource for doing symbolic calculations. Now you should note before we look at some examples, the syntax in Mathematica is certainly different than the syntax in MATLAB. And going back and forth between the two can be confusing since some things are kind of the opposite in Mathematica versus MATLAB, or just the way that we do certain things differs between the two programming softwares. So one, when we are using Mathematica, all the built-in functions must be capitalized. So things like sine or cos for cosine should have a capital S or a capital C. Anything that Mathematica has built into its toolboxes is going to be capitalized, and there is a difference between a capital COS and lowercase cos. It won't know what lowercase cos is for cosine. The functions are also defined differently when you make them. We can't use the same method we use for making either inline functions in MATLAB or a separate M file. That will be different in Mathematica. In Mathematica, all the functions take the square brackets to open and close. So again, going back to the sine and cosine example, if you want the sine of pi over 2, you would do capital SIN open bracket, square bracket, and then the number in radians, pi over 2, and then the closed square bracket. Again, this differs from MATLAB where we use the round parentheses for all of our functions. And also in Mathematica, unlike MATLAB, we're going to have our code in cells. Now in MATLAB you can do cell mode, and it's probably a little bit different, but a similar idea to what we do in Mathematica. But in Mathematica, we typically run one cell at a time. So just be aware that you're not rerunning your entire code every time you run your Mathematica code. Typically, you're going to be running it one cell at a time. So it's not necessarily always going top to bottom in the way Mathematica is running. It's going to go in the order that you run the cells, whether that is top to bottom, or if you're moving back and forth between different cells. Just be aware that just because you changed the value of a variable in a previous cell, if you don't run that cell, it's not going to update that variable when you go to use it later. So we'll go through some examples in Mathematica using different functions, different features that we are going to be utilizing in this course to get you up to speed, to be comfortable to use it on homework assignments and in projects. But like I said earlier, we are going to be using MATLAB as well to do mostly the number crunching and the graphics. Although Mathematica can also do plotting and it can do number crunching. In my opinion, at least, Mathematica is much better for symbolics than MATLAB is, even if you're using the MATLAB symbolic toolbox. I like the way Mathematica displays it. I think it's friendlier to use, and the functions are more robust in Mathematica to handle symbolics. So for symbolic things, algebraic things, I really recommend using Mathematica. If we are doing things with numerics, that is, we are simply crunching numbers and getting an answer, we're not trying to use algebra or rearrange variables, for that, I'm going to say use MATLAB. MATLAB, I think it's also easier to handle the graphics, like doing plots, than Mathematica is. But again, Mathematica can do plots. The syntax is a little bit trickier, I think, than using MATLAB, though. And we're going to be using MATLAB in conjunction with Simulink when we get into control systems and analysis later in the course. So you're definitely going to want to be working in MATLAB in preparation for using it along with Simulink for those parts of the course.